Hey everybody, how are you? My name is Christian Smith. I'm head of go-to-market. Maybe you've seen me on Storage Day where I presented SaaS and analytics. I think the most memorable part of that is I was the guy wearing the big hat.
Hey, hello everybody. Rajesh Vijayaraghavan here. I'm part of the storage business development team. I look into the small, medium business set of customers.
So this session will be build with efficiency, agility, innovation of the cloud with AWS cloud storage. And this will be a 100-level session, so we'll talk a lot about the various use cases and applications and how they map into storage. We're going to just do a quick level set and start out. Look, cloud storage has gotten a lot more complex these days. We're supporting a lot of cloud-native use cases and workflows, along with building new capabilities to support, enterprise data center apps moving over to AWS and providing you with the same features, functionalities, resiliency, availability that you expect out of deploying those apps in AWS. Today we have 14 storage services that act on data and 37 different storage classes. And all of these were built from taking a look at what customers needed and working backwards from there to turn those into applications and use cases. Our goal is to make sure we're mapping the right applications and use cases into the right classes of storage. I'm going to take and do 2 slides, and we're going to talk just about kind of the overall storage, portfolio, and then we'll dive into some of these use cases. So, when we think about our storage services at AWS, there's some certain design patterns that we think about. We don't want you to have to worry about these things. So we think about all of our storage services need to have these characteristics, that they're scalable, that they're secure, that they're performant, that they're fully managed so that you don't have to do a lot of the heavy lifting, that they're cost optimized, and that they're deployed globally. So this is how we think about providing our storage services to you as you use and consume those. And when we dive into our storage services, let's just give a quick overview of what those are. We have our primary data storage services in 3 categories. We have our block services like EBS. We have our object services like S3 and S3 Glacier. And then we have our file services, which is our FSX family and our EFS family. We then have a lot of services that help you move data in various use cases. So transfer family, think of this as business to business. Like I need to exchange data with peers. Snow family, I need to move data from offline into AWS or back again. Gateway, I need to access my data from my data center. And I need to be able to have sort of a different experience than just accessing it natively. And then data sync. Data sync is your just bulk data mover. It just keeps pipes busy. And then we have various data protection services to protect all of this across AWS. So whether you talk about AWS backup, our native snapshot capabilities, or our elastic disaster recovery. And really let's think about this as this is all to put your data to work. So when we say putting data to work, we mean things like how do you do analytics? How do you do machine learning? How do you run your high-performance compute environment? How do you run business-critical applications? Because we have such a wide portfolio of services, you can do a lot of these things in different ways. If you ever feel like your expectations are not being met by using our storage services, you should get in touch with us. So for example, we see examples where customers are moving from on-prem to AWS, and they'll over-provision their storage by the normal 2 to 3x because on-prem is brittle. It's hard to deploy, it's hard to get more capacity, so they think 3 to 5 years out we may use this, so therefore let's provision this. We've helped customers save over 60% on their storage costs just by right-sizing them. Additionally, we've seen customers who said, my job takes way too long. It's not finishing in time to get the results I want. And so in there, we'll help marry something like file storage with object storage so that your jobs just run faster. Okay? So this is our portfolio of offerings. We have a lot of depth. Again, as I mentioned before, this will be just kind of taking an opposite approach of looking at the application use cases and bringing it into the storage class so you get a better idea of where to start.
Thanks, Christian. So data, right? Data is the new oil. So in today's business landscape, there is a large growth of data, right? So you are producing data either within your organization from your applications, or there is market data that is coming in, or at the edge, the IoT devices are creating more data, right? So as a business, you are trying to leverage all this data to gain valuable insights, right? What's the point of just having the data if you're not using it, right? So with all this data comes a lot of challenges. So businesses must address security concerns, privacy concerns, and comply with regulations, right? So along with having all this data stored efficiency, you also need to deploy new initiatives like machine learning, to draw insights from this data. So by deploying advanced analytics and machine learning on the data, businesses are able to extract actionable insights and analyze the trends and even predict what's going to happen in the next week or next month, right? So you can also build and scale all your applications seamlessly as you take on new customers and markets, right? So storage or data plays a key role, and AWS storage is there to help you on this. So let's talk about the storage value proposition when it comes to your workloads, right? So in my role as a principal business development manager for storage, I distinctly see three phases that or patterns that customers use with AWS, right? So some customers, when they start off with the cloud, they have a limited amount of time to get out of their data center or colo location. So they just want to simply migrate whatever environment they have on-prem. They're bringing directly in a lift and shift fashion to AWS, right? So once they move it into AWS, they have a little bit more time to think through the strategy, and that's where they start modernizing these applications. They try to move more towards the managed services, and when it comes to compute, they're going to start using container or serverless strategies. After doing these, then they further right-size their instances or their application workloads. They move to like fully elastic offerings such as elastic file system, or they also use some of our intelligent tiering strategies when it comes to S3 or EFS. So it's a continuous journey. It doesn't just stop with lift and shift or modernization. They continue to evolve and start using more services from AWS. Now, how do you think about the cost reduction, right? Cost is still top of mind for customers. So as I mentioned, when customers initially migrate, do a lift and shift, there in itself, they get like 20% cost savings because of the elasticity, the price elasticity of the cloud, pay-as-you-go nature of the cloud. Once they start doing the right sizing of their applications, go to the move to managed services, again, you can see the slope going down, right? The costs keep coming down. And then once they move to serverless or container strategies, further TCO savings, right? So close to like 60-70% savings they get from all the three phases once they are done. Along with infrastructure savings, it doesn't stop there. Customers we've seen have also been able to lower their downtime hours by 7x. They've been able to get more than 60% higher worker productivity. And they've also been able to ship more features, 3x the number of features than their prior strategy. So AWS storage is a key component in all these different phases. And let's now dive into these strategies there.
So these are the design patterns we're going to be talking about today. So as I mentioned before, this is looking at the use case and working our way into storage classes here. And so we're going to talk a lot about the first part of this, about migrating some applications into AWS. Then we'll move into some builder-based modes of whether deploying a data lake or talking about machine learning or containers. And then we'll follow up with data protection. And when we talk about these data use cases, wrong button, there you go. We talk about these data use cases, there are hundreds and thousands of these things. And as I said before, we're doing something different in this talk of working from the applications in. If you go to a lot of sessions this week, I'm sure that you'll hear all great things and deep dive into our services. And we've got a great set of 200, 300, 400 level services and labs. But a common pattern is you're going to go walk into an FSX meeting, and they're going to talk about it's great for media and entertainment, financial services, lift and shift applications. Then you'll walk into the EBS meeting, and they'll talk about exactly the same thing again. And what we're trying to do here is help guide you a little bit better to like start thinking of these things. And then if you ask questions, we'll have a set of use cases that come up below that. So let's get started. We're going to talk first about IT-based use cases and really like talking about design for business critical applications, right? So think of this as a little bit of like sand in the cloud. And we talk about sand in the cloud, there's a lot of reasons why customers are moving these types of applications over to AWS. Like it's a cost reduction. It's about driving innovation. Like how do I interact with other types of services within AWS? It's executing faster so that I can provision more, drive more test dev and QA, be able to utilize this data to do other things. It's about scale, being able to deploy in a global footprint or environment. And when we talk about these types of use cases, they're Windows-based apps, they're SAP, they're databases, it's our mainframe modernization, it's the VM environments, and of course, we talk a lot about like rehosting this stuff into AWS to take advantage of the things that I had mentioned. Since this is a pretty broad topic, like there's a lot going on here, we're just going to start kind of high level and give you 2 examples and show you how we're starting to build these design patterns differently based on applications and use case needs, right? So we're going to focus specifically on database workloads, and we'll give you 2 examples, and then we'll move into VM stores here. This will be a great talk because, like I said, normally we talk about like IO2BX and how great it is with IOPS, but we wouldn't quite guide you correctly to the right things, or talk about elastic volumes and the ability to move to different types of volumes dynamically on the fly. All good examples of how you build agility into your workflows. But more often than not, customers were like, hey, just tell me where to start. And so that's this conversation. Not going to cover this slide in depth, but we do give you a lot of choice. And we give you a choice on the operational needs. We give you choice on the TCO. We give you choice on the availability of the deployment mode you're going after. So for example, you can go all the way to deploying MS SQL and RDS, and you don't even have to manage the database. We do it all for you. You can do it in standalone modes. You can do it in high availability modes. If you ever want to manage your own databases, and there are many reasons why people want to manage their own databases, we have different types of modes. You can go down the path of just deploying EC2 and EBS. If you want to create some sort of availability difference, right? I want either single AZ HA or I want multi-AZ HA using SQL Standard, I can deploy with EBS or Amazon FSx. Or if I want to go to enterprise license SQL, I can deploy with enterprise SQL with always-on availability groups and get true, segmented HA between AZs. So again, all of these map to a TCO availability, but it starts pulling you down to what am I trying to do with this application. I can do the same thing with HANA. So we're seeing a lot of customers start to migrate their HANA environments over. You can say the same thing with Oracle. Again, we're starting to build these 2 model views here, which is, hey, I have a set of criteria that I'm deploying my HANA environment in. Maybe I don't need full RTO, RPO. I'm using it for reporting or something like that. Or I've got truly an HA-like deployment that I need not only test dev QA, I've got to replicate it to other environments. I'm deploying scale-out HANA on top of that, and that's going to have a different deployment mode. And of course, each one of these deployments will be optimized to getting the most out of it from a performance and cost perspective. Okay? Let's shift gears and talk about VMware, or VMware Cloud on AWS is the official term. And more and more customers are starting to migrate their VM environment over to AWS as the first start. Like we have 2 modes where people are taking their VMware environment and deploying it as native AMIs. And then another mode is, hey, I want to preserve the operational experience of my VMware environment, use my VMware tools. I would like to deploy that on AWS also. And our current mode of VMware Cloud and AWS works really well, especially when you're trying to evacuate a data center, where you can just really quickly stand it up, use VMware tools to move all that over to AWS, and then continue on that optimization journey thereafter that Rajesh described. The way that we've deployed VMware Cloud and AWS, it's a node-based deployment where you get a node with a fixed-sized amount of compute, memory, and storage attached to it. And it works really great when you're deploying in compute-heavy workloads, meaning where I just need a lot of compute, but I'm not going to necessarily use all the data that's attached to that. We've extended some new capabilities that you can now deploy in what we call data-heavy workloads, where I don't need to deploy nodes with unused memory and compute just because that's the fixed size. I can actually add FSx for NetApp ONTAP into that and now optimize my TCO for data-heavy workloads. So we're continuing to innovate, and you'll see some announcements around VMware Cloud on AWS, which even changes this further this week. A good example of leveraging critical applications, this is Salesforce.com. They were looking at a MongoDB application for their ML environment doing inference. And what was happening is they were deployed on standard general purpose EBS. And so it was a question of, do I need to re-architect, or can I do something to bump that performance up? And what they were able to do is deploy an IO2BX, tune up their IOPS, and they were able to get faster rendering of their ML prediction algorithm. And what was important about this is customer facing. And so anything that's sort of predictive has a customer experience on it. You need to be quickly responsive when you're executing these queries, making suggestions. And so therefore, Salesforce went with IO2BX and was able to accelerate that customer experience. It's Vegas, hydrate. Let's talk about design for file-based applications in the cloud or file in the cloud. A lot of applications today run on premises are file-based. And as a matter of fact, if you look at on-prem, most of it's kind of 50-50 between SAN and NAS in a lot of enterprise environments with a small amount of object, which is significantly different than when you deploy in AWS. When we talk about these applications, we kind of bucket them into kind of 3 use cases or categories. There's just the general purpose file shares, your user groups, your home directories, your group shares, where people need to interact with data in a files and folder format. And then there's a whole series of ISV-based applications that just run on file. And these applications range from everything from, yes, databases, but also to vendor-specific things like Perforce for software builds, to Murex for financial services, and the list can go on and on and on. Or they're using it as repositories for fast data protection. DBAs, just dumping database backups into a file share because it's easy to use for test dev and QA, or you're replicating on-premises environments into AWS. The best way that we have taken those environments and translated them to AWS is by taking 4 of the most commonly available file systems. So NetApp ONTAP, OpenZFS, Windows File Server, and Lustre, and package them up as a managed service. You just launch, click, and run. It's that simple there. And we really pick these so that it helps you in your journey of deploying in AWS. So when you deploy like this, what happens is I don't need to retrain my team. I don't need to recertify my applications. A lot of these ISV apps have kind of certification processes associated with it. It means I can get up and running quickly. I don't have to re-architect my solution right out of the gate, and I can start taking advantage and getting some of the cost savings that we talked about earlier. And these are truly like-for-like deployments. I can take a NetApp environment on-prem and replicate it to a NetApp environment in AWS. I have a command line, I have AWS APIs, and I have ONTAP APIs. If I'm a Windows admin and I'm really comfortable working with Windows File Server, the experience is going to feel pretty much the same. Or if I just have general Linux shares or ZFS, I can get this up and running really simple, easy file system to get going. So the benefits of both our file and block offerings and offering fully managed services is really about just speed and agility, right? So I can go faster, I can move faster, I don't have to worry about new complexities, I can lower my cost. The part that we talk about, though, that makes this easier is we do a lot of the heavy lifting for you. So no OS upgrades, patches have to worry about. You don't have to worry about procuring new things and deploying them in a data center. Capacity management, really easy just to extend capacity and grow globally. You don't have to worry about that patching issues associated with it. License management, we all embed that in the cost of what you're procuring through us or using through us. And then we add some goodness here in terms of integrating with various backup capabilities so you have like a complete solution. What I like to say is just like in today's day and age, there's a lot of things we're all trying to do. We're all trying to juggle, a task list that's growing ever long. Kind of taking away those things that kind of get in the way of servicing your customers or servicing the business or scaling the business is what we are operationalizing for you. Here's a great example. In 2021, we released FSx for NetApp ONTAP. One of our earliest customers was eHealth New South Wales. They had a large on-premises NetApp environment. They were able to replicate their DICOM data to AWS using native SnapMirror tools, get that up and running really quickly and didn't have to deploy a secondary site. Their team didn't need to be retrained on how to do this. They got it operational really quickly, and now they're starting to look at migrating more of their ONTAP on-premises applications over to AWS. I'm going to give it to Rajesh.
Let's talk about data lakes, right? So let's look into what it takes to build a data lake with AWS. So when you think of a data lake, first thing is what are the types of data that you have, right? You may have it in different formats, JSON, Parquet files, CSV. There are so many different types coming out every day, right? You may have it as an image file or audio file, depending on the nature of your business, right? Even videos or database files. You could be storing these already in some cloud, or you may have it all in on-prem, right? So it'll be anywhere. One thing is we don't want a siloed data strategy. We don't want data in different places and you moving it to, for your applications to make use of them. So when you're thinking of a data lake, you need to bring all this data to a central location. And then once you have all this data, you can run analytics and draw insights from it, right? So once you have this data in a central data lake, you could run analytics on it. As I said, you can, use this data for your high-performance computing clusters, and you can use QuickSight or Tableau, any of the visualization tools that you have. And finally, with the Gen AI gaining precedence here, you can use machine learning on this data to, make business decisions. But what this entails is you need a strong foundation for this data lake, and that's where S3 comes in, right? So the first thing to decide is where you land the data, and S3 is the best place, right? It's the foundation of all data lakes. So when you think about a data store, right, like S3, there are multiple dimensions you need to think about, like the scalability of it, the security, the ecosystem integration. And, when it comes to scalability, just some factoids here. S3 holds 200 trillion objects and averages over 100 million requests per second. That's how scalable S3 is. From a security standpoint, S3 offers a variety of encryption options from server-side to client-side encryption. When it comes to access control, you can leverage IAM to implement either an identity-based or a resource-based policy. When it comes to ecosystem integration, S3 integrates with a variety of AWS analytics and machine learning services such as Redshift, Athena, Glue, EMR, to name a few. And even third-party software, if you've been working with Snowflake or Databricks, you can still use the data from S3. Lastly, we have different types of data lakes. So if you think about verticals, we have an auto-specific data lake. We have a security data lake. We even have a healthcare-related data lake, right? So we have curated the essential features there, and you can now build those data lakes on S3. Storage class choice matters for folks building data lakes on S3. We have all these options, but we have to map the value of your data to the cost of storing it, right? That's where when we talk to customers, they think S3 is like this monolithic one-class storage. It's not. It's got so many different classes. So I'll go through some of these. So S3 standard is for data that is frequently accessed. You have millisecond level access to this data. For infrequently accessed data, you can use lifecycle policies and tier it to S3 infrequent access. If you're looking for a less expensive option, and if the data is recreatable, right, you have it somewhere on-prem, you're just storing it on AWS just as a backup copy, then the single zonal option, we call it one zone IA, that's a good choice there. You still get millisecond level access. And a few years ago, we introduced Glacier Instant Retrieval. So this class of storage is, you still get millisecond level access, but this is for your data that you want to archive it, you want to use it 2 or 3 times per year, right? So, and then there is long-term compliance data. There are customers that want to store data for 5 years or 7 years. That's where Glacier Flexible Retrieval and Glacier Deep Archive come in. So for the data that you land on those classes of storage, you need to be aware that your applications have to restore the data and then use them, right, if you have to use that data. But we have a lot of customers that say, hey, I don't have the time, or I don't know about the access patterns. What do I do? Like, where do I store, right? That's where intelligent tiering comes in, right? So S3 intelligent tiering is, we are using our machine learning algorithms to monitor your objects, and depending on the access patterns, we will land it in the right tier for you. So we'll dive into that a little bit more. Since we have launched intelligent tiering on S3, we have saved more than $1 billion for our customers, right? So that's the meta point I want to point on this slide. The way S3 intelligent tiering works is when you assign your objects in a bucket to intelligent tiering, we start monitoring those objects. S3 monitors, and for the first 30 days, it's going to be in the frequent access tier, which is similar to your S3 standard class of storage. Let's say those objects are not touched by your applications, not accessed by your applications, then tiers down to the infrequent access tier, which is similar to the S3 SIA tier. And another 60 days goes by, and if objects are not being accessed, then it tiers it down to the archival instant access class of storage. So with each of this tiering down, you're going to start saving on your S3 costs, right? So from going from frequent access to infrequent access, it's 40% saving, and another 68% saving from going from infrequent access to the archive instant access. We don't stop here. So for customers that want to keep tiering the data, you can opt into 2 other classes of storage, the archive access tier, which is similar to Glacier Flexible Retrieval, and the deep archive access tier, which is similar to the Glacier Deep Archive, right? So what we have come to realize is most customers are directly landing their objects on S3 intelligent tiering. It's a fit for most of the workloads. So as a customer use case, we'll talk about Thompson Reuters. Thompson Reuters is a company that you all are familiar for their news reporting. They're aggregating all the events that's going on. So with Thomson Reuters, they had a project where they had to launch an analytics platform within 5 months, right? Like they wanted to visualize all the information that they were getting from their news reports. And they wanted to create a platform that had the best data protection with encryption, and they also wanted it to be scalable, right? Like they wanted to have thousands of events stream in, and the application should be able to work with it, right? So the company worked with us using S3 as the data lake, and they used Kinesis to stream the data into the data lake. And using Lambda, they were able to do the compute in a serverless fashion, right? So since using S3 as a data lake, they've been able to process 4,000 events per second, and they can even scale up to like 10,000 events if they need to be. There has been no data loss or downtime in this whole process. And they are able to simultaneously stream with Kinesis and also do batch operations with this solution.
All right. So I don't know if any talk could be complete without talking about AI/ML these days. This is a huge surface area right now, and there's everything from building your own LLMs to using LLMs and tuning them to doing just standard AI/ML to do predictive inference. I'm not going to talk about all that, but I'll give you just kind of a high-level view of the pipeline. The biggest thing to think about is that this is a very data-centric space. And it's kind of changing the way people are thinking about their data retention and centralizing data for use in their environment. And so when we talk about, AI/ML, it almost has to start with the data strategy. What am I actually doing with all the data we have? How am I centralizing it? How am I putting controls on it? How am I setting retention policies? Who has access to that data? How should I think of governance? How do I actually get rid of the silos that exist between my applications today? And we really mean everywhere. It goes everything from your databases that you're running to the kind of logs and IoT-based data and the human data that you have in your environment to be able to use this to go train things. Again, this isn't I'm going to go do it all at once, but there's going to be a progression where this continues to be consumed and with new services and new capabilities that will eventually touch all the parts of your organization from a data perspective. So from that data strategy, I think there's several different presentations. I strongly recommend kind of going to a couple of those and figuring out what do you need to think about from a data perspective moving forward. What I am going to talk a little bit more, though, is the pipeline, and realize that this is a bit of a different pipeline than most applications, because it's everything from I have to prepare, build, train, deploy, and manage, and there are people and machines in this pipeline, both, right? And they have different needs and different capabilities to interact with that data. And so we'll do a click down, and this looks a little complicated, and it is, because there's a lot of things that are going on here. But it starts with how do I centralize that data? How do I curate those things in that data that I'm going to use? How do I start building my model? This is data scientists interacting with the data, thinking about what model they're going to choose and what parameters they're going to, the breadth of parameters they're going to use. This is all human in the loop stuff, people interacting with all of this data. And this is both SageMaker and, your own self-managed AI/ML to I'm going to use the AWS AI services. And then you get to the next phase, which is training, which is very compute intensive, right? And so this compute intensity is far different than just, say, your standard EC2-based compute. This is, P4s. This is our Trainium and Inferentia services, and these types of servers have I/O needs to be filled. They can consume a lot of data fast. And so how do you optimize that data flow into those? And then you go into deployment with ML ops. And this is where you put your model to work and you start to deploy it, and people interact with that model in a way to derive insights. And then, of course, you do it all over again as your data continues to grow, and you sort of tune the model over time, and this cycle just keeps repeating itself. The interesting thing here we're going to focus on as this pipeline is, S3, whether you're going to take your data lake and you're going to extend your data lake into your training model, S3 is a great place to start that. Whether you're going to build net new is just coming up with a plan, and how do I aggregate all that data into sort of central repositories for use. As I process it, what kind of tools am I using? Do I need people with files and folders? Do I need people with interfaces? How am I interacting with that data? And then on the training side, and this is what we're going to talk about a little bit more of some uniqueness of things that we've thought about and done based on customer demand, which is specifically GPUs can be really hard to saturate. And when you talk about one kind of P4, P5 instances versus 5, the bandwidth change is pretty dramatic in that motion where you've got to keep these busy. And why do you want to keep these busy? Well, you keep these busy because this is cost. And this is most of the cost in your AI/ML environment is doing this type of training. And so idle GPUs are costing you money. So you want to keep those saturated as possible. And then also there's a secondary effect is if I don't keep them busy, my training runs get longer and longer, and so I can't iterate fast. We have done something pretty unique, is that we've married both the sort of central source of truth of your data with S3, with FSX for Lustre. And so you're able to attach Lustre to your bucket. It will hydrate that data on first access, but allow like sub-millisecond, sub-microsecond performance to serve your GPU needs as you continue to scale out. So this is going to keep your GPUs busy. The other cool part of that is as you're doing things like checkpointing, if you're writing data and you take checkpoints because it's a multi-day event, it'll checkpoint back to FSXL. And when you finally get your model run figured out, it'll sync it all back to your central source of truth again. So you have this like accelerator on top of your data to help you. And this is exactly the case with Netflix. So Netflix uses AI/ML. They use it for a lot of different use cases in their environment. But they were doing large-scale distributed training for their own ML media models. Now, what was happening is they were taking and using what we call node local storage on P4 and P5 instances. There's like, storage attached to those. There's like 30 terabytes. And so what they were doing was syncing all the data first to these instances before they were doing their runs. Well, from a workflow perspective, that adds time. You got to wait for the data to sync. You have challenges that if you bring new data in, you got to resync it to the instances again. Or if you lose an instance because you're only using it for a short period of time, you got to resync that data back. By introducing FSXL into this, they were able to decrease their time from a week to running their training model to 1 to 2 days. And they were able to see a 4x improvement in their overall pipeline. Now, I'm going to switch gears because nothing would be complete without talking about containers and serverless. The interesting, this is an infrastructure conversation again, right? When you talk about containers, this is just moving from fixed compute to container compute, right? And making it easier to deploy applications. So containers become your predictable run environment. You can scale them up, you can scale them down. You can distribute software this way. You can run, predictably. You can compartmentalize your business logic, right, with containerized offerings. We have some great container offerings with everything from serverless with Lambda to not having to worry about EC2 with Fargate to deploying EKS and ECS as a managed framework. Now, with containers, the idea is to deploy these stateless so that you can swap them in and out as needed. If anybody's a developer in here, we know that's harder to do than what people actually do, but technically they're supposed to be stateless. And you're supposed to use some persistent store for that data. The good news is all of our file offerings, all of our object offerings, and all of our EBS offerings now are integrated with our container services, so they can capture that persistence. Because the class of applications that are running in containerized environments is so broad, the best thing I was trying to do is pull together just a little bit of a test, right? Like how do I start to think about what type of service, what type of storage I'm deploying for my application need. And it really aligns to a lot of what we've talked about already. If you're doing databases, you probably want to use something like an EBS interface. If you need to scale your data to hundreds of petabytes, you're probably going to use more of an API to access that data. If you need kind of the low latency throughput mode, or your application that you're containerizing only talks to a file interface, you want to use a file interface for what you're doing. And so this is a good kind of model just to ask some rudimentary questions and kind of guide you toward a given storage service. There's an interesting pattern we've seen start to emerge in this, though. As customers are building more multi-AZ available containerized environments, they're starting to use a lot more file services in this because our file services span multiple AZs. And so you don't have to worry about that hard binding of compute, EC2 for your container, to EBS and have to deploy like for like. You can sort of let it deploy anywhere, and then you don't have like the cross AZ charges for accessing your data, and you have that high availability application that can deploy anywhere in any AZ within that region, which is more important as computes become more challenging to deploy, to get. And we see these use cases in everything from enterprise apps being containerized all the way to a lot of the machine learning frameworks to analytics-based applications. It is really just a wholesale shift of this is how people are deploying today. And a good example of this was T-Mobile. So they had their on-premises microservices environment that they were running. And they moved to AWS, and they shifted that over to a multi-AZ EFS environment. So now their containers can go into any number of different AZs in that environment. And that data is then persisted and accessed from any one of those AZs with true consistency. In addition to this microservices environments, they're also deploying their CI/CD pipeline, they're deploying websites, and what they were able to do is kind of from an application perspective, they realized a 40 to 70% savings per applications, and then they reduced their complexity and also sped up their deployment times by 15%. Okay? All right, last topic, data protection, critical part to any strategy.
Yeah, data protection, right? It is front and center for all kinds of customers, whether small, medium business or big enterprises. So when it comes to data protection, what we've seen is, customers have been doing data protection forever, right? You might be working with Veritas, Commvault, or even some of the new players, Rubrik, Cohesity. So there are multiple ways of doing data protection. Some customers, use our storage gateways, come up with a hybrid strategy. They land their data on S3 and they manage their backups and such. But what we've come to see is all the backup vendors, they integrate with S3. So even if customers are using any of these vendors that I mentioned, their APIs can point to S3 and a copy of their data. Maybe their customer is using an on-prem appliance from them. Those data copies can be moved on to S3. We also have the capability for these ISV backup vendors to integrate with AWS backup. So for the data that is generated within the cloud, again, you can use the backup APIs and use AWS backup. With AWS backup, customers are able to centrally deploy data protection policies. You can do the configuration, management, and governance of the backup activity supported across multiple services. So these are the 15 different services that AWS backup is already integrated to. So again, you will be able to do a fully managed backup using AWS backup. You can tag, you can create your own backup policies. You can, use these plans against your backup requirements. Like several companies have different compliance requirements. You can also schedule the frequency of your backups and retention of these backups, right? Like a lot of customers don't want to keep multiple versions of these backups. So currently, AWS backup supports these 15 stateful services. We are continuing to integrate more services, and along with we have the hybrid support for VMware now. We are including more services into the backup portfolio. As I mentioned, these are some of the backup and recovery partners that we have in the Amazon Partner Network. So you could be working with any of these vendors on-prem. We have vetted these solutions, make sure that it works with our AWS backup solution. So they have shown their technical proficiency here. So you could definitely work with any of these vendors, and they can connect to either AWS backup or S3. For a customer use case, let's talk about Workday. Workday, as you may know, is a HRIS, Human Resource Information System company. They were coming up with a product called Workday Extend that enables their customers to build custom apps deploying into the Workday tech stack, right? So they had a lot of end user clients who had, who were heavily audited, and they had stringent backup requirements, right? So before using AWS backup, Workday relied on automated point-in-time recovery. They lacked the central management feature for backups, and they were only able to provide like 30, 35 days of retention for these backups. They also had to take manual snapshots of all the backups, whether it was EFS, RDS, DynamoDB, whichever service they were using, and they had to manage this retention very closely for their customers. After onboarding AWS backup, Workday was able to easily automate all these tasks. They were able to, meet the complex demands of their customers. And, the audits for their customers were much more simplified with AWS Backup. And their developers were now able to focus on, enhancing their products rather than, maintaining these backups and retentions. We've covered a lot of things today. Again, this is just a teaser about all the services that we have. There are a number of sessions related to AWS storage that will dive into some of these use cases and applications. But we don't want it to stop in this room, right? So you can find a learning plan. There is a website, AWS Skill Builder, so you can go there and start taking courses at your own pace. There are ramp-up guides that if you want to just concentrate on, let's say, file storage or object storage, you can use these ramp-up guides to come up to speed on those. Lastly, what has been so popular in the last few months or this year is the storage badges. So depending on the area that you're in, whether it's data protection or object storage or block storage, you can go through these courses and take some tests and get certified on these. And these have been great to show on LinkedIn as well. So there's a QR code here if you want to continue your learning. Again, thank you so much for being here on the first day during the lunchtime. So hope you have a great reInvent the rest of the days.
So real quick, please give us feedback on this. Like, we're forever trying to get better at how we simplify the journey to AWS. This session was a little bit of a shift in how we normally talk about our storage services. And so we'd like your feedback. So does it work? Does it work? Do you need more depth? What would help you out? So please give us the review on this if you don't mind. And thank you very much for your time.
We are going to be here for the next 10 minutes or so. If you have any questions, feel free to stop by. Thank you.